Welcome back to Math 103. This is video number 7 on voting. Last time we were looking at head-to-head competitions between candidates. And in this particular election, we found that in the head-to-head competition between A and B, A was the winner. Looking now at A versus C, we find that there are 8 ballots on which A is ahead of C, plus another 3 ballots on which A is ranked higher than C, but there are only 10 voters who rank C higher than A. Therefore, A wins by a score of 11 to 10. Okay. There are more voters who rank A higher than C than there are voters who rank C higher than A. Finally, what about B versus C? Well, in that head-to-head competition, B wins, also by a score of 11 to 10, because there again, there are 8 plus another 3, that's 11 ballots that rank B higher than C, but only 10 ballots that rank C higher than B. Overall, what just happened, there were 3 different ways of pairing up the candidates, 2 at a time, and in these head-to-head competitions, in each of which we asked, what if the election came down to just 2 people, who would win then? In both of A's contests, A came out the winner. This brings us to our next important idea, that of a Condorcet candidate, named after the Marquis de Condorcet, a very important and influential 18th century French nobleman and mathematician. A Condorcet candidate in an election is a candidate who defeats every opponent in head-to-head competition. Given the preference table of an election, there is no guarantee that there is a Condorcet candidate at all, just as there is no guarantee that there is a majority candidate. So we can ask about the election we were just examining, is there a Condorcet candidate in that election with that preference table? And if you think about it, we've already done all the work. We've shown that A defeats all opponents, defeats both B and C in head-to-head competition, and therefore A is a Condorcet candidate. Notice that it's important that A actually defeat all opponents. It's not enough to defeat some and tie others but never lose. It's actually necessary to win outright every single head-to-head competition. And also be sure to always say Condorcet, not Condorcet. If you say Condorcet, then don't tell anybody that I was your math professor. Now here's another example based on our election from the beginning of the chapter involving Pat, Sam, and Alex. This is a little more complicated. The question is whether there is a Condorcet candidate in this election at all. It's not obvious at all just looking at the preference table, so I urge you to pause the tape and work this out before continuing. To see if there's a Condorcet candidate, we have to see if there is one candidate who defeats both of the others in head-to-head competition. So just for the heck of it, I'm going to start with Pat versus Alex and see what happens. Well, Pat is ahead of Alex on which ballots? These 4 plus those 14, that's 18 so far, plus these 5, that's 23, whereas Alex is ahead on the other 27. So it follows that Alex wins 27 to 23. And just for the heck of it, the next one I look at will be Sam versus Alex. And now let's see what happens. Well, Sam is ahead of Alex on these 4 plus those 5 plus those 15, that's 24 so far, ballots. And Alex is ahead on the other 26. Therefore, Alex wins this one as well, 26 to 24. Therefore, since Alex has defeated both P and S, both Pat and Sam, We don't even need to see whether Pat beats Sam or Sam beats Pat. The question was to find whether there is a Condorcet candidate, and there is, and it is Alex. So Alex is a Condorcet candidate. And this is good to know. Why? Because there's a certain intuition that maybe that's an argument why Alex represents the overall will of the people in this election. After all, if Pat won under some voting method, Alex could say, hey, wait a minute, most of the voters would rather have me than you. And if Sam won the election by some voting method, Alex could reply, hey, majority of the people prefer me to you. Either way, Alex has a good argument why it would not be quite right for anyone else to win the election. This brings us to our second fairness criterion, the Condorcet criterion. If there is a Condorcet candidate in an election, then that candidate should be the winner. Of course, there might not be a Condorcet candidate at all, in which case the Marquis de Condorcet has nothing to say about who should win, but if there is a Condorcet candidate, then that's who the winner should be. Now, what does the election, with the preference table we've been looking at, tell us about whether each of the voting methods we've studied so far never violates or sometimes violates the Condorcet criterion? This is a good question. Pause for a moment and think about what this is asking. Let's look at each voting method in turn. The plurality method, the first method we looked at, declared C the winner. But that's a problem from Condorcet's point of view, because A is a Condorcet candidate. So from Condorcet's point of view, the plurality method has elected the wrong candidate. And so the plurality method violates the Condorcet criterion in this particular election. The larger conclusion, then, is that the plurality method sometimes violates the Condorcet criterion. By the same thinking, the instant runoff voting method declares that B wins this particular election. By the same logic, the instant runoff voting method sometimes violates the Condorcet criterion. We found one instance in which it produces a violation. Therefore, we cannot say that it never violates. The only other option is that it sometimes violates the Condorcet criterion. Okay, and finally, there was the board account method. Now, the board account method declared that A wins. Now, let's be careful here. It declares that A wins, and therefore what happens in general? So Borda got this election right from Condorcet's point of view. By the way, Borda and Condorcet historically were contemporaries. Borda got this right from Condorcet's point of view. Condorcet is happy, but in real life they had many disagreements, and their election methods do not always produce the same results. So just because Borda elected the right candidate from Condorcet's point of view in this election doesn't mean that he will always do so. Therefore, there is no conclusion about whether the board account method sometimes or never violates the Condorcet criterion. We can't tell just from this election. We'll have to either wait until we find an election where board account does violate Condorcet, or it may turn out that the board account never violates. We don't know yet. It's one way or the other. We've encountered two special kinds of candidates in elections. A majority candidate is one special kind of candidate, a Condorcet candidate is another special kind of candidate. And we can ask, is there any relationship between these two? In particular, is a Condorcet candidate necessarily also a majority candidate? And we can ask, is a majority candidate necessarily also a Condorcet candidate? Maybe yes, maybe no. We have to reason it out. So let's look first at whether a Condorcet candidate is necessarily also a majority candidate. I claim that the answer to this question lies in an example we were just working on. So pause and think about this for a moment. Is a Condorcet candidate necessarily also a majority candidate? The answer is no. The answer is no, because A is a Condorcet candidate in this election, as we have found, but A is not a majority candidate. So there is nothing about being a Condorcet candidate which requires you to also be a majority candidate. So in that respect, we don't find a relationship between the two. But I claim that in the other direction, there is a relationship, that being a majority candidate entails being a Condorcet candidate as well. Before going on to the next video, explain why this is true. Explain why a majority candidate is necessarily also a Condorcet candidate. And use the following example to help illustrate. This question is asking you to do more than just observe that C is a majority candidate and is also a Condorcet candidate. I mean, that's true in this example, but try to see why it makes sense that having a majority of first-choice votes is enough to make C a Condorcet candidate as well.